This video shows the proof that a tangent drawn to a circle is perpendicular to the radius at the point of contact. So we're going to prove that the tangent QR is perpendicular to the radius of the circle, OP. And we're going to do this by contradiction. So it's going to be a proof by contradiction. We're going to assume that angle OPR isn't a right angle, and that there must therefore be another point on the tangent such that the angle is 90 degrees. So we're going to place that point T on QR such that angle PTO is a right angle. Okay, now I'll summarize all that for you now. Okay, so let's go through that again. Assume angle OPR is not a right angle. So that's why it's a contradiction. We want it to be the right angle, so we're going to assume it's not. So there must be a point on that tangent such that the angle is 90 degrees. So we're going to place point T on QR such that angle PTO is 90 degrees. So we're saying this angle here is 90 degrees. Okay? So if that's true, therefore angle PTO must be the largest angle in that triangle. Okay, so this is our triangle here. If that PTO is 90 degrees, it has to be the largest angle in the triangle. So that means angle PTO has to be greater than angle OPT, which is one we actually want to be a right angle. Okay, remembering angle OPT equals angle OPR. Okay, it also means that the side OP has to be longer than the side OT. Okay, because OP is the hypotenuse. Which is the longest side. Remembering our hypotenuse is opposite the right angle. But if you look at the diagram, OP has to equal OS because they're radii. Okay, so OP can't be greater than OT. There's our contradiction. Therefore, the original assumption is incorrect. Which implies OP is perpendicular to QR. So a tangent drawn to a circle is perpendicular to the radius at the point of contact. And the proof is done. So the code, if we're using this in other questions, so we need to state that the tangent's at right angles to the radius, is just that there with a little right angle in the corner. Now note, Cambridge does this slightly different. So Cambridge on page 329 has a slightly different proof that you might want to look at.